So Es'hail-2 is the next session, and that's going to be what we're talking about, launch arrangements, coverage and all the rest. However, somebody has just told me that later on today, the chairman of the British Amateur Television Club has got a couple of dubious photographs of the current president. So I wanted to get my oar in first. So here is a photograph of your chairman, erecting an antenna at Goonhilly, which no doubt somebody will talk about later. But please note the wet patch on the roof, because it had been raining, and the complete wet patch on his left cheek, because he sat in it. So there we are. We have witnesses, don't we, Dave?
We do.
Okay, so launch arrangements for Es'hail-2. You've heard various of us talking about Es'hail-2, and is it going to launch this week, next week, sometime? Never. I've never been really confident of exactly when. I'm certainly more confident now. End of the fourth quarter of this year is what is being said. Now, you can take that with a pinch of salt as well. I have no more detailed knowledge that I can't impart. We really don't know. Somebody must know, but we don't even know whether the spacecraft has yet made it to the States, to America. It's being launched, as it says there, from Cape Canaveral. That's the plan. So your guess is as good as mine, but I think it's a more real date now than we've had before. I did nick this off the internet. Those in the front can probably read it. This is a schedule for SpaceX Falcon 9 launches. This was actually written in August, so the line there is August, and Es'hail is here, and there's this sort of big gap. There are various launch sites. That's Vandenberg, which is a completely different site on the other side of America. I'm quite interested because we've got a couple of AMSAT UK payloads on that launch. Looking at these ones, which are the Cape Canaveral one, they've got two launch sites there. At Cape Canaveral, I think one's at Kennedy and one's at Cape Canaveral, but they're very close. So there's not anything else scheduled before Es'hail, because Telstar, I think, has already gone. So, yeah. So it appears to be the next one on the manifest.
It was scheduled for in October, and then suddenly it became Q4.
Yep, so we don't know. My other suspicion is this Dragon V2, which is the first launch of an unmanned Dragon. Is that going to the space station?
Yes, it is.
I suspect they'll be concentrating a lot on that. It's not the same launch site. Well, it's the same launch area. So your guess is as good as mine. But it is going to be fairly soon. So now is the time to start preparing. Coverage. Again, you've seen quite a few maps. I think this is one that I produced, so it's no better than anybody else's. It just uses Nova, but it looks down to 0 degrees. Most coverage maps you'll find for broadcast television satellites normally show down to about 5 degrees, I think, because they don't assume that anybody's going to be idiotic enough to try and go on top of a hill and look at 0 degrees, just do things like radio amateurs do. But so this shows that there's quite a lot of Brazil. So there is a bit of America, notwithstanding that the US is sort of left out. Obviously all of Europe and across to Malaysia and the edge of Thailand and places there. Australia, sorry. I think they've got Christmas Island, haven't they? So if they want to go to Christmas Island, you could get a VK from there. And then all of Africa. And then those that are really mad will want to go to South Georgia, down here, or Tristan da Cunha, which is it's islands on the air gone mad, plus Antarctica. There are some bases in that bit of Antarctica, and up the north, which doesn't show on this chart, Svalbard and places like that, and Greenland, of course. So it's got an immense coverage. The problem is, though, that it's a global beam, but we really don't know much about the link budget. We know that they're using standard TWTs. We know that there are two transponders, which I'll talk about in a moment. There are two transponders, a narrowband one, you've seen this chart before, a narrowband transponder that is 250 kilohertz wide, and a wideband transponder that's 8 megahertz wide. Now remember that normal transponders on broadcast broadcast satellites are, I don't know, 27 or 30, 32 or 35 meg wide. So somewhere in the spacecraft, it's being filtered down. How that's affecting the gain, the sensitivity, in space terms, we talk about link budgets. I think there's an awful lot of unknowns. There's also an awful lot of unknowns about this definition of the passband, the bandwidth of the passband. Is it steep-sided and flat across the top, or will it be more gentle, and all of the implications there. Plus, the uncertainty, the fundamental uncertainty about the antenna. I understand there are horns, both on receive and transmit, but is the radiation pattern completely flat, or does it fall off a bit at the sides? So are you going to need much more power at the edges? I assume you probably will, but how much more power, we really don't know. So just talking about the transponder, the narrowband transponder is right down at the bottom of the amateur satellite band, which goes from 2.4 gigs to 2.45. It's down right at the bottom, or near the bottom, to be, in theory, on the band edge of the ISM band, the Wi-Fi. We've got, again, unknown what level of noise, of Wi-Fi noise, is heard in geostationary orbit. It is assumed not very much, but we actually don't know. So there's 250 kilohertz there, and then further up, with a sort of guard band there, is the 8 meg wide one for digital TV. And then the downlink is the sort of same. And again, we're near the very top of the amateur satellite allocation. The amateur satellite allocation goes from 10.450 to 10.5 gigs. We're right at the top there because the TWTs are spec'd down. The broadcast band goes down to 10.69, 10.7, yeah, 10.7. So they're operating slightly out of their nominal band pass or design frequency. So we want to be up as close as possible. There's details there. The uplinks are both right-hand circular polarization, and the downlink, the narrowband is vertical, and the wideband is horizontal. So there's some separations there. Don't think that gives us any particular problem in receiving, but we have to remember. Now, talking of preparations, you will have seen down by the hangar, there's a couple of dishes which we just thought would be really nice to be able to show BADA-4. BADA-4 is a spacecraft that is already active. There are actually three, BADA-4, 5 and 6, that are active from the same spot, 26 degrees east. It's already there, and they've got one beam, one spot beam that covers the UK at a fairly high EIRP, and the signals from there, I won't say easy to receive. You need a big sky dish, a region 2 sky dish, or something of that size. And we were going to demonstrate that down at the other hangar. Unfortunately, like many ad hoc demonstrations, I think the answer is you should never act with it, children, animals, and new dishes that you haven't used before. So that failed as a demo. But a number of us have actually received signals from BADA-4. They're all in Arabic. You'll recognize that you've got the right one. There's one, the frequency that I've shown there, 11996, horizontal, it's got a BBC News in Arabic and a whole load of other things. And as I say, I've received it both on a biggish dish and a big sky dish.
There's a whole load of information on the forums.
There is. So, that will get you set up. In terms of timing, I suppose I should actually just clarify, okay, the spacecraft gets launched, and then as we were discussing last night, there's a in-orbit testing period, which will be done, we believe, from another location on the Clark Belt. It won't be at 26, it will be parked somewhere else while they do initial testing. Whether that testing will include our transponders or not, again, we don't know. So whether we'll need initially to move the dishes around a bit, we've got no idea. But that will probably take 8 weeks, 12 weeks testing before it's moved, allowed to drift back to the correct location of 26 East. No idea when our transponders will be switched on. You perhaps cut a national day on December the 16th, but that's possibly being way too optimistic. Anyway, so preparations, that's what we can get set up with BADA-4. A proposed narrow band plan. IARU have now just woken up to the fact that this satellite is probably going to exist, but there are no IARU band plans for this spacecraft yet. So this is a proposal which may or may not see the light of day, but basically it takes the 20-meter band plan and moves it up 10 gigs. So that's fairly simple. The narrowband transponder has two beacons, one at the top of the passband and one at the bottom. The beacons, anybody who's worked Oscar 10, 13 and 40 in days gone past will know that there's a sort of old established beacon format which is 400 BPS and BPSK with some FEC. It's very low, relatively low data rate. You have to receive it green on black screens. It doesn't work on anything more fancy. And we're actually not quite sure what's going to be in that beacon because historically it was the telemetry from the spacecraft, but what we have on the spacecraft are only two bent pipe transponders. So that beacon will be or those two beacons will be generated on the ground. So next up, one of the things that we're obviously aware of is the risks that we're running exposing amateur radio to this point in the sky, which a transponder where it won't be easy to get into, but once you've got into it, you don't need to move anything or adjust anything, because once you've got the aerial pointing in the right direction, unless the trees grow through the summer, that's about your only risk. So we do need to be very careful about what we do. And in general, I mean, it's like a repeater. We've all experienced 2-meter repeaters where people have done stupid things and eventually they've been switched off. Yeah? What we don't want to happen is that with either of these transponders. So I suppose everybody should be trying to lead by example and respect the facility and other users, as it says there, and don't do anything that may cause offence, like don't use it like 80 metres and don't talk about your latest hip operation or the pills you...
That's all we talk about at our age.
Yeah, see? Or anything that's outside your terms of your amateur radio license. Right, and don't run too much uplink power. You can't actually break the transponder, but you can break it for any other user because eventually it will overload. On the narrowband one, there's something called LILA, which will come up and will put a siren on top of you, so you'll know you're too strong. On ATV, particular do's and don'ts, well, they're fairly obvious things that the sort of protocols that we adopt or do adopt through our terrestrial repeaters. Keep the overs short. Use a web monitor to verify your uplink power. Dave will talk more about that in a moment, and also use the chat room, which is being developed. Use DVB-S2 if you can, because that's much more spectrum efficient. Do experiment. Don't show images or videos of stuff that steam trains, I think, are particularly forbidden, aren't they?
Canal boats.
And no canal boats. Oh, no. He wasn't in the room. I missed that. Can we rewind? And don't transmit anything that would cause offence, like steam trains or canal boats. And don't show recordings of non-amateur events. That's going to be an interesting one. And obviously don't show any copyright material for which you don't own the copyright. So that's what's going to happen. I think, assuming it does happen, and it really works, it's going to change quite a lot of what we do as ATVers. Nothing like as much, though, as it's going to change what the people who are going to be using the sideband, narrowband transponder. It will change IOTA and SOTA and every because it's always going to be there. Anyway, carrying on, the next slide is Dave, who hopefully, the next session is from Dave, who hopefully has got a...
Do you want to try and put that
Yeah, do. Okay, yeah. We have a small technical challenge here. We may need to take 20 seconds. Spectrum monitor.
Yeah. It's at the minutes because the projector's like
You're going to tell me when to do it?
Do what? No.
No. Okay. We're back on there.
Down arrow to.
Thank you.
So,
Thank
over
you.
to Dave for the next part of the session.
That's interesting.
Oh yeah, have you done that?
No, I didn't do anything.
You talk amongst yourselves.
Very nice desktop. Oh yeah, just click the click that icon down there. No gold. Escape. Right, we got that. Having great fun then, aren't we?
You know what I did? So I can undo it.
Right, that's yours. That's mine. Right. Yeah.
Can you go from there?
Probably. No. Sorry. Booby trapped, aren't I? There we go. And we'll do a bit of F5. F5 work on this. Oh. There you go. Yep. Good. Okay. Thank you. Sorry about that. I'm just going to talk briefly about the spectrum monitor, the what, the why, and the how. Why? That's a good thing. I got the order wrong. Why? It's the first time that we've been transmitting amateur TV where people are going to get upset if you give them too loud a signal. You know, usually you just turn it up until it starts to distort, take it back a bit, whether that's digital or analog. It's not that easy to listen for activity. Usually you've got an ATV back channel on 750 or something where you know it's going to be a 333 kilosymbols transmission with 7/8. You don't know that on the satellite because you probably can't talk to the guy. And as we know, mini-tune isn't the easiest thing in the world to tune around. You can't just sort of tweak up the band and look for the pictures. So, first step in this is to come up with a band plan, and this has been primarily the BATC's role to propose one to the German guys who are very good at the narrowband stuff, but asked for our expertise on the wideband stuff. So this is the proposed band plan. It may not survive contact with the enemy. I don't know who the enemy is, but it may not survive contact with them. Essentially, at the bottom end here, we're going to have a beacon to start with to help people line up their dishes. It's probably going to be a 2 megasymbols, i.e. just under 3 megs wide. But as soon as we can, I want to get that beacon down to a narrow beacon so we have less bandwidth being occupied by a beacon and more bandwidth for amateur radio. And I'd like that beacon to go off during the day or at certain times so we get the full bandwidth available to play with. In this segment here, you can either have a 2 megasymbol signal or 2 1 megasymbol. So that's all receivable with a normal set-top box. We do the same with this bit here, but the bit over to the right there is where we're going to play with RBTV, and those of you with small dishes and low power, that's where you'll be. Either 333 kilosymbols or 125, I suggest we stand on. At least then you've got a chance of guessing what's going on. Uplink and downlink frequencies are there. Note there's a bit of confusion, or potential for confusion, in that there's a half meg displacement in the uplink frequency compared with the downlink. It doesn't quite work. Okay, so the spectrum monitor doesn't show up very well on that screen because it's dark green on black. Essentially, it's going to be a web page. Left-hand side will be this, with a view of the spectrum, and there you can see there are 3 signals. You can just see 5 signals. One there. Don't know whether we can turn these lights out. Thank you. Great. 1 signal there, 1 signal there, and 3 more across there. Now, you could probably have a guess at what they are, but if you then overlay that on the band plan, you know, what do people think we've got there? Any idea, you know, what that might be? I reckon that's a 333 on one of those frequencies. So this is why we've got the band plan and, you know, recommendations. If that was the beacon, what's wrong with that signal? Too loud, yes. So, you know, it will provide you with a means to set the right level and also a means to work out what's going on there. To the right-hand side will be a chat screen. It will look very much like any of the chat screens on the repeater streams or your personal stream. What? Well, we've got a 1.3 metre dish at Goonhilly. We took a dish to Goonhilly. I can't believe we did that. It is on the roof of the support building for what used to be Goonhilly 2 that's no longer there. And we have the use of a room inside. I was going to pass this around. Please be careful with it. It's got the cover off. That's the LNB, and this is the new version of the Octagon LNB. The old version had 27 meg reference and 2 PCBs. This one's got 1 PCB with a 25 meg reference. That's the LNB we've got at Goonhilly, and when that one is sorted out, that will be GPS locked and will be installed at Goonhilly. We've got inside that LNB feeds in through a bias T, which is this board here, into 2 air spies. So we take both outputs, a horizontal and a vertical, feed it into 2 air spies. The air spies are GPS locked, and as will that be GPS locked with 25 megs going up the LNB cable to GPS lock it. And that's a Leo Bodnar GPS receiver. So that's the tray of equipment. That's just power supply stuff on the left-hand side. And that goes into a Linux PC, which sits next to it on the desk in our equipment room. Linux PC, i7, quite a powerful machine, which should cope with plenty of users. And we hope to put on it the wideband spectrum view, the chat server, and a web SDR for the narrowband segment, hence the 2 air spies. At this point, I was going to do a demo of it because we can get an online connection to the prototype, but I can't get the PC on the projector. So I won't do that demo. And the result is it'll look something like that. So in the right-hand side there, I see conversation like transmitting on 10498, 2 megasymbols, 78 FEC, and underneath that, what's the signal at 10499, and so on. And that's how I see it being used. Any questions? Microphone, please.
Which GPS module do you use to GPS lock this?
It's a Leo Bodnar 150 quid GPS module. They're very sensitive, can be programmed for 2 separate outputs within limits. There is got to be some relationship between the 2 frequencies, but for us it does 10 megs and 25 megs from one GPS source.
What's the phase noise like?
Very good. Yeah. Yeah, I'm not sure there's much better around there. Sorry? Or available direct from Leo Bodnar, actually. Yeah. Yeah.
Hi, Dave.
Hi,
A
Jim.
couple of observations. First one is that I guess initially they will have to find the optimum operating point for the transponder because you'll have to back off the output sufficiently. Also, that band plan may lead to, if you don't have sufficient back off, a third order intermod issue, whereas you have 2 carriers which are normally offset by X, and the third order intermod will be plus X, which will fall into the narrowband segment. So I guess there will be a bit of playing around with levels to start with, just to make sure that everything is, I would say, linear and so on.
The narrowband, actually the intermod won't fall in the narrowband segment because that's a different polarity.
Sorry, I meant the narrow DATV segment, not.
Yeah.
So just looking at the television aspect.
Yeah, there is
so
potential for that, and it's going to be a learning experience.
I think
for
there's
us.
going to have to be as you say, a learning experience, trying different size carriers and seeing what the effects are.
Yeah,
So a bit of guesswork to start with.
absolutely. Yeah. Kieran? Yeah, sorry.
Yeah, is there a list or is there a guide to where we can, for example, find all the like phase lock loop LMBs and suitable amplifiers, etc.?
I think we'll do a CQTV article and a
Okay.
wiki page on
Right.
basically the information that's on the forum at the moment from people experimenting.
Sure. Yeah.
Needs putting onto the wiki and then a CQTV article.
So
Yeah.
there is already 2. In the last couple of days, I've put 2 things on the wiki. We will put more stuff on the wiki. Most of this presentation will be in next Radcoms. So we're getting there. We're
Right.
getting that information out there. But we just hope that we get a launch. You know,
Sure. Of course. Yeah. Yeah.
It's that compromise.
Yeah.
Okay.
Any other questions? Any other questions? No? Yeah, I think the level, adjusting the uplink level is going to be an interesting challenge, both for the narrowbanders and for us transmitting TV. So that's some good behaviour that we're going to have to insist on. If not, the Qataris have got a very nice fleet of Mirage jets, which I'm sure they have a need to use.